Welcome to 2.4, Mass and Weight. Here is a review question. The apple is falling. What direction does the apple move? Well, we know that the apple moves down. Why? Because of gravity. Because of gravity. Now, question. True or false? There is no gravity on the moon. What do you think? Well, let's see. When the astronaut jumps on the moon, the astronaut comes down. So yes, there is gravity on the moon. But when the astronaut jumps, it takes a longer time for the astronaut to come down. See, it takes a long time for the astronaut to come down. When the astronaut jumps, it takes a long time for the astronaut to come down. So when the astronaut jumps on the moon, the astronaut comes down slowly compared to the Earth. Why? Well, we will understand this today. So today we will learn about mass and weight. Mass is how much matter stuff is inside. Weight is the force of gravity pulling down on us. Well, if it's a force, the formula is Newton's second law, F equals ma. But instead of using acceleration, if we know it's gravity, we can use a different letter, g. G just means gravity. We know on Earth, g is about 10. Or acceleration is about 10. So really, it's just this formula. Sometimes people write it this way, but it's the same thing. Because weight is a force. For example, the mass of Mr. Louis is 70 kilograms. What is Mr. Louis' weight on Earth? We know on Earth, the acceleration is about 10 meters per second squared going down. So we know that we're looking for Mr. Louis' weight. Weight is a force. It's the force of gravity. So we don't know the force. We don't know the force. We know mass is 70, acceleration is 10, F equals ma. So F equals m is 70, acceleration is 10. 70 times 10 is 700. So my weight on Earth is 700 newtons. We know with weight is going down. Example 2. The weight of an object is about 600 newtons on Earth. What is the object's mass? So we are looking for mass. We don't know mass. We know that the weight, which is the force, is 600 newtons. It says on Earth, so acceleration is 10. Same formula. The force is 600. So we know that the force is 600 equals the mass, we don't know, and the acceleration is 10. To solve this one, we divide both sides by 10. This time we divide because we have a number on the left of the equation sign, a number on the right. We are really saying what number times 10 is 600. When we do that, so when we divide by 10, we get 60 equals m. So the mass is 60 kilograms. Mass and weight are different because the mass is the same everywhere. How much stuff is inside is the same everywhere. But the weight is different. How much force is different because gravity is different on Earth, on the moon, and in space. They are different. For example, my mass is 70 kilograms. My mass is about, well, let's see. I'm about 160 pounds. If we go to Google, I can type 160 pounds, 2 kilograms, and I get 72.5, let's say about 73 kilograms. 73 kilograms. So my weight on Earth, force equals mass times acceleration. Force, my mass is 73. Acceleration on Earth is 10. So my weight is about 730 newtons. On the moon is different. Same formula, same mass everywhere. But the acceleration on the moon is only about 1.6. If we put this in the calculator, 73 times 1.6, I get 116.8. So my weight is about 730 newtons on Earth, but only 116.8 newtons on the moon. So I weigh less on the moon. To summarize, Jim Valdrino's mass on Earth and on the moon are the same. But Jim Valdrino's weight on Earth and on the moon are different. Our weight is greater on Earth than on the moon. Here's an MCAS question. It says, what is the mass? So we don't know mass. Weighing is a force. So the force is 63 newtons. And it says Earth. We know on Earth, gravity is about 10. A or G is about 10. So A equals 10. Same formula. So the force is 63. Mass is, we don't know. And acceleration is 10. Divide both sides by 10. And I get about 6.3 equals m. So the answer is B. Mass is 6.3 kilograms. Okay. Let's go back to our question earlier. Why does the astronaut come down slowly on the moon? Well, that's because the weight, force of gravity, and the acceleration is smaller on the moon. Smaller acceleration, the astronaut will come down slower. I also have linked to a song. You can listen to it on your own time. It's a really good song. And also, this song is great because the teacher also puts the lyrics here. Okay? So you should watch the song if you have time. That's it for this video.